galaxy. The good news is that, therefore, this scenario does not work. It is not right. This scenario predicts that we should be a minimal fluctuation. Even if you get our galaxy out, you would not get 100 billion other galaxies. And Feynman also understood this. Feynman says, from the hypothesis that the world is a fluctuation, all the predictions are that if we look at a part of the world we've never seen before, we will find it mixed up, not like the piece we've just looked at, high entropy. If our order were due to a fluctuation, we would not expect order anywhere but where we've just noticed it. We therefore conclude the universe is not a fluctuation. So that's good. The question is then, what is the right answer? If the universe is not a fluctuation, why did the early universe have a low entropy? And I would love to tell you the answer, but I'm running out of time. Here is the universe that we tell you about versus the universe that really exists. I just showed you this picture. The universe is expanding for the last 10 billion years or so. It's cooling off. But we now know enough about the future of the universe to say a lot more. If the dark energy remains around, the stars around us will use up their nuclear fuel, they will stop burning, they will fall into black holes. We will live in a universe with nothing in it but black holes. That universe will last 10 to the 100 years, a lot longer than our little universe has lived. The future is much longer than the past. But even black holes don't last forever. They will evaporate, and we will be left with nothing but empty space. That empty space lasts essentially forever. However, you notice that since empty space gives off radiation, there's actually thermal fluctuations, and it cycles around all the different possible combinations of the degrees of freedom that exist in empty space. So even though the universe lasts forever, there's only a finite number of things that can possibly happen in the universe. They all happen over a period of time equal to 10 to the 10 to the 120 years. So here's two questions for you. Number one, if the universe lasts for 10 to the 10 to the 120 years, why are we born in the first 14 billion years of it, in the warm, comfortable afterglow of the Big Bang? Why aren't we in empty space? You might say, well, there's nothing there to be living, but that's not right. You could be a random fluctuation out of the nothingness. Why aren't you? More homework assignment for you. So like I said, I don't actually know the answer. I'm going to give you my favorite scenario. Either it's just like that, there is no explanation, this is a brute fact about the universe that you should learn to accept and stop asking questions. Or maybe the Big Bang is not the beginning of the universe. An egg, an unbroken egg, is a low entropy configuration, and yet when we open our refrigerator, we do not go, how surprising to find this low entropy configuration in our refrigerator. That's because an egg is not a closed system. It comes out of a chicken. Maybe the universe comes out of a universal chicken. Maybe there is something that naturally, through the growth of the laws of physics, gives rise to a universe like ours in low entropy configurations. If that's true, it would happen more than once. We would be part of a much bigger multiverse. That's my favorite scenario.